শূকর সম্পর্কে একটা ধারণা প্রচলিত আছে যে ওরা জঘন্য, ওরা নোংরা প্রাণী এবং সবাই চায় ওদের মরে যাক। আর আমি এমন কিছু লোকের সাথে কথা বলেছি যারা হেলিকপ্টার দিয়ে শিকার করতে যায়, আর আমি তাদের জিজ্ঞেস করি, আপনারা এতগুলো শূকর নিয়ে কি করেন? তারা বলে, ওগুলোকে ওখানেই ফেলে রাখেন। আমি বলি, কি? হ্যাঁ, আমি বলি, এটা তো ঠিক মনে হচ্ছে না। টেক্সাস
stock tank because it was one of the few reliable water sources on the property during a dry summer. What came off those memory cards over the following week would end up circulating through wildlife biology departments at 3 different universities, and it would force more than one expert to quietly reconsider what they thought they understood about how feral hog populations actually collapse. This is the story of that footage, and of the far stranger explanation that came after it. Ainsworth's ranch sits in the rolling country west of San Angelo, roughly 900 acres of mesquite flats and cedar breaks that had been in his family for 3 generations. Like almost every landowner in that part of the state, he had a hog problem, not a minor one. Sounders numbering in the dozens moved through property most nights, tearing up irrigation lines, rooting through pasture land he needed for cattle, and generally making a project out of destroying anything he'd spent money maintaining. He'd tried the usual tools, corn-baited traps that worked for a week or 2 before the survivors got wise to them, a contract with a local removal outfit that came out with thermal scopes twice a month. None of it made a dent that lasted. So when he found 31 dead hogs in one clearing, his first assumption was that a rival landowner, or maybe a poaching crew looking to sell carcasses off the books, had done something drastic and left the evidence behind. What the trail camera footage showed instead didn't fit that theory at all. The clearing had been full of hogs for at least 6 nights before the deaths, all captured on camera drinking from the same stock tank. Nothing unusual there. Then, on the 7th night, the footage shows the sounder arriving as normal, moving with the loose, unhurried gait hogs use when they don't sense danger. Within about 11 minutes of the first animals reaching the water, several of them begin to stagger. Not run, not startle, stagger. The way a large animal moves when its legs are no longer fully under its own control. 2 piglets go down first, then a mature sow, then in a slow, uneven wave that spreads out from the tank over the next 40 minutes. Nearly the entire group collapses in place. There is no predator in the frame, no vehicle, no human figure, just animal after animal folding to the ground in the green-white wash of infrared, in a clearing that by morning would be a crime scene with no crime. Dell's cousin sent the footage to a contact at a regional extension office, who forwarded it to a veterinary pathologist because the pattern looked, to an untrained eye, disturbingly like poisoning. That was the first theory anyone seriously considered, and for good reason. Illegal poisoning of feral hogs isn't common. But it isn't unheard of either, and the symptoms on camera, the loss of coordination, the collapse, the timing clustered around a single water source, were consistent with a fast-acting neurotoxin. A field necropsy team drove out within 48 hours. They collected tissue, blood, and stomach content from 6 of the carcasses and sent water samples from the tank to a lab for a full toxicology screen, checking for everything from strychnine to organophosphates to the kind of unregistered rodenticide that occasionally shows up misused on rural properties. Every result came back clean. No synthetic toxin, no heavy metal contamination, nothing in the water that shouldn't have been there. That ruled out the simplest explanation and left investigators with a harder question. If nobody poisoned these animals, what killed 31 hogs in under an hour in a pattern precise enough to look engineered? The second theory was disease, specifically one of the swine pathogens that wildlife agencies have been watching closely for years. Feral hog populations are a known reservoir for pseudorabies and classical hog collar-type viruses, and outbreaks can move through a dense, unvaccinated population with brutal speed. But disease outbreaks, even fast ones, don't usually produce a die-off that's synchronized. Sick animals typically show a staggered progression over days, not a mass collapse inside a single feeding window. The necropsy team kept the pathogen screen running anyway, because ruling out disease matters just as much as ruling out poison when you're dealing with an animal that shares habitat with livestock. It was a third set of results, the ones nobody had prioritized because nobody expected them to matter, that finally explained what the cameras had captured. The stock tank on Ainsworth's property was old, spring-fed, and had been low all summer thanks to a drought that had settled over that stretch of the Edwards Plateau for the better part of 3 months. Low water in a stagnant tank during extreme heat creates conditions that most ranchers know to watch for, though usually in relation to livestock rather than hogs, a bloom of blue-green algae, more accurately cyanobacteria, capable of producing toxins potent enough to kill an animal within the hour if it drinks enough contaminated water. The lab results confirmed it. The water carried a heavy concentration of a cyanotoxin associated with a specific type of algal bloom, the kind that thrives in exactly the conditions that tank had that week. Still water, high temperatures, and a nutrient load built up from months of animal waste concentrating around the shrinking waterline. It wasn't a poison anyone had placed there. It was a naturally occurring hazard that had been quietly assembling itself in that tank for weeks, waiting for the right combination of heat and drought to reach a lethal concentration, and then waiting for enough of the local hog population to funnel through a narrowing set of water sources at once. That last part turned out to be the detail that made the story bigger than one dead sounder on one Texas ranch. Wildlife biologists who reviewed the case pointed out something that hadn't been part of the original inquiry at all. Drought doesn't just concentrate toxins in isolated water sources. It also concentrates animals. As smaller ponds and seasonal creeks dry up across a property, wildlife of every kind gets funneled toward the handful of water sources that remain, which means more animals drinking from the same tank, more waste accumulating around that tank, and a faster, more dangerous bloom cycle than would occur in a wet year with water scattered across the landscape. Feral hogs, with their large body size, high water intake, and habit of returning to the same reliable source night after night, are particularly exposed to this kind of event during a bad drought summer. In other words, the die-off on Ainsworth's ranch wasn't an isolated freak accident. It was a preview of a mechanism that was quietly playing out in smaller and less dramatic ways across a much wider stretch of hog territory that same season. Once the Ainsworth case was written up internally, a handful of researchers started pulling old field reports and necropsy logs from other Texas counties going back several years, looking for smaller versions of the same pattern that had simply never been flagged as related. What they found was a scattering of isolated incidents that, individually, had each been chalked up to something else. A rancher in Menard County who found 9 hogs dead near a nearly dry tank 2 summers earlier and assumed heat stroke. A wildlife survey crew in Coke County that logged an unusual cluster of hog carcasses near a stagnant pond during a heat wave and noted it only as an anomaly in an otherwise routine population count. None of these had been tested for cyanotoxins at the time because nobody had reason to look for them. Laid side by side, the pattern was hard to ignore. Every documented cluster mapped onto a drought year. Every one involved a shrinking water source rather than a flowing one. And every one occurred during the hottest stretch of summer, when bloom conditions are most favorable and when animals are drinking the most water per visit to compensate for heat loss. What made this genuinely surprising to people who study hog population dynamics for a living wasn't that algae could kill wildlife. That much has been documented in livestock and waterfowl for decades. What surprised them was the possibility that this mechanism might be quietly functioning as real, if irregular. Check on feral hog numbers in exactly the regions where human removal efforts have struggled the most, the dry, water-scarce ranch country where trapping and helicopter operations are expensive, infrequent, and hard to sustain over a full season. It's an uncomfortable idea for a wildlife agency to sit with, because it means one of the more effective, if unpredictable, pressures on a runaway invasive population is tied directly to drought severity, which is itself becoming less predictable and, in many years, more extreme. A wetter year with abundant surface water scattered across a landscape removes the crowding effect almost entirely, and the die-offs essentially don't happen. A brutal drought year concentrates animals and toxins together and produces exactly the kind of event that played out on Ainsworth's ranch. For the first few weeks after the story circulated, most of the attention understandably went to strangeness of the footage itself. 31 animals collapsing in near unison in a clearing with no visible cause. But the part that field researchers kept returning to wasn't the die-off. It was what happened on that property in the months afterward. Ainsworth expected the surviving hogs on his land to simply regroup and continue as before, the way they always had after a trapping operation thinned a sounder. That's not what happened. Trail camera activity around the old stock tank dropped to almost nothing within 2 weeks and stayed low for the rest of the season. Hogs that had used that water source nightly for years began avoiding it entirely, showing up instead at a smaller seasonal creek, nearly half a mile further from the pasture land they'd been tearing up. Researchers who study hog behavior after mass mortality events describe this as a documented, though poorly understood, avoidance response. Surviving members of a sounder, and especially juveniles who witness a die-off, appear to associate the specific location with danger and steer clear of it for an extended period, sometimes an entire season or longer. It isn't full comprehension of what killed the group. It functions more like an inherited caution, the same instinct that makes a sounder avoid a field where a trap was recently sprung, except in this case the avoided location was a life-sustaining water source rather than a piece of human equipment. The practical effect on Ainsworth's property was a genuine, if unplanned, redistribution. Hog pressure on his damaged pasture land eased noticeably for the rest of that year, not because the population had been meaningfully reduced in absolute numbers, but because the remaining animals had relocated their core activity away from the area he cared most about protecting. It wasn't a solution he could have engineered on purpose. It wasn't one any removal program had a name for. It was simply the land doing something none of his traps, none of his contracted hunts, and none of his fence repairs had managed to do on their own. None of this has turned into a new official strategy, and researchers are careful to say that deliberately manipulating water sources to induce algal blooms will be both legally fraught and ecologically reckless, since the same toxins that kill hogs are just as dangerous to livestock, pets, deer, and the birds that share those same tanks. Nobody serious is proposing that ranchers try to recreate what happened on Ainsworth's property. What has changed in a handful of counties is how closely extension offices are now tracking small stock tanks during drought conditions, treating them less as a minor maintenance concern and more as an early indicator worth monitoring for exactly this kind of bloom risk, both as a hazard to livestock and as a data point in understanding hog population pressure. A few pilot programs have started testing whether targeted aeration systems, the kind normally installed to protect cattle from toxic algae, might have a secondary benefit of preventing die-offs that biologists have started to view less as a pure liability and more as a genuinely mixed event, tragic for the animals involved, but occasionally useful as an unplanned check on population density in the hardest-hit drought years. There's also a renewed interest in something researchers had mostly stopped paying close attention to: the long tail of behavioral change that follows a mass mortality event. If avoidance really does persist for a season or longer, and if it really does shift pressure away from vulnerable land, that's a variable that hasn't been factored into most regional management models at all. It suggests that the aftermath of an event like this might matter more, in practical terms, than the death toll itself. Dell Ainsworth still has the original memory card from that night, and by his own account he's watched the clip more times than he can count, less out of scientific curiosity than a kind of lingering disbelief. 31 animals had outmaneuvered every trap, every hunt, and every fence repair he'd thrown at them for years, undone in under an hour by a shrinking pond in a heat wave, with no human involvement of any kind. It wasn't a massacre in the sense the word usually implies. There was no shooter, no coordinated cull, no dramatic intervention. It was quieter and stranger than that, a landscape under enough stress to turn one of its own water sources lethal, and a population dense enough and thirsty enough to walk straight into it without a single warning sign. What came after? The avoidance, the redistribution, the sudden and unplanned relief on one small stretch of Texas pastureland turned out to be the part worth paying attention to. Researchers combing back through years of overlooked field notes are still trying to figure out how often this has quietly happened before, unlogged, unexplained, and written off as heat stroke or bad luck. The honest answer for now is that nobody knows the real scope of it. What they do know is that a phenomenon nobody had been tracking turned out to be doing something, in the driest and hardest years, that decades of funded removal programs had never quite managed on their own.